Very sorry for the delay. Good morning, everyone. Sorry, good evening, everyone, guys. There is some issue with my laptop. The screen is not able to set properly. अभी तो भी issue तो resolve नहीं हुआ, थोड़ा सा edge cut हो रहा है. इसके लिए बहुत टाइम से ट्राई कर रहा हूँ, नहीं हो रहा है. So sorry for the delay, guys. I'm very sorry. So मेरा हेल्थ में कोई इश्यू नहीं है. आई एम फाइन. ओके. Who told any issue with me? I am very fine. Thank you very much. Okay. So good evening, everyone. Welcome to the session. Without any further delay, so let me solve the questions I have picked up from the PYQ. Those are the toughest possible questions given in the past 30 years in the GATE. So we will be doing the questions from network analysis. इसके बाद अगर टाइम मिलेंगे तो maybe I will solve these questions also, what we call digital circuit का. I am extremely sorry for the delay, guys. I am very sorry for keeping you awaited for long time. So अभी तो Unacademy पे नया बैचेस भी शुरू हो गया. So digital circuit started on 28th Jan at 5 p.m. You can subscribe to this batch with the new offer also available with Unacademy that is available up to tomorrow. So you have the offer up to 31st Jan, that is up to tomorrow. You can save up to 30%. You can use my code Shankar10 to avail the maximum discount. So let's start the questions. So without any further delay, so this is the first question. This is the question given in GATE 2008. 2008 पे दिया ये वाला क्वेश्चन, बोथ ईसी और इलेक्ट्रिकल का. आईएससी दिया उस साल पे पेपर मेरा, हाँ हिसाब से आईएससी दिया. सो दिस इज द क्वेश्चन पेपर एंड द क्वेश्चन हियर, आई होप यू कैन डू इट. इट्स अ डुएबल क्वेश्चन. सो वेरी गुड इवनिंग वंस अगेन. सो लेट्स स्टार्ट. थोड़ा सा स्लैंट है क्वेश्चन, प्लीज एडजस्ट करो. इसके लिए एक्चुअली मेरा क्लास तो डिले हो गया, मैं एडजस्ट किया मैक्सिमम. सो इसके लिए थोड़ा और टाइम लग रहा है, इसको छोड़ दिया. ठीक है. सो क्वेश्चंस विल बी लिटिल स्लैंट टुडे, प्लीज काइंडली एडजस्ट दैट पार्ट. ठीक है. सो चलो भाई, आज का क्वेश्चन क्या था. सर्क्यूट शोन इन द फिगर इज यूज्ड टू चार्ज द कैपेसिटर अल्टरनेटिवली फ्रॉम द टू करंट सोर्सेस एज इंडिकेटेड. सो टुडे आई विल टीच यू हाउ टू रीड द क्वेश्चन प्रॉपर्ली. Most of the questions I have selected, you can see there are different sort of questions. Most of the questions are little lengthy in nature, so that you will get the what we call time to read the question properly, and you can do the things in a proper way. All these questions are PYQ. If you have already attended my regular classes in Plus or YouTube, मैं तो all possible tough PYQs तो class पे solve किया. But if you have missed by some chance, you can watch these particular session. All these questions will be solved. पल्स दिया तो क्या होता है, लॉकस डायग्राम का एक क्वेश्चन दिया, टू पोर्ट नेटवर्क पे नेटवर्क थ्योरम्स का, and a good question of this one. All these good questions are there today. So let's solve this first question. Okay. So आप भी ट्राई कर सकते हैं, बट ज़्यादा टाइम तो नहीं देना चाहिए. मैंने आपको चाहिए तो मैं आई कैन गिव यू 1 minute ऑफ टाइम. इसके बाद आई विल स्टार्ट द एक्सप्लेनेशन. ठीक है. सो 1 minute तो टाइम दे सकते हैं. मैंने ज़्यादा टाइम दिया तो द सेशन विल बी मोर लेंदी, एंड बिकॉज इट इज़ योर एग्जाम टाइम में आपका टाइम वेस्ट नहीं करना चाहिए. सो एज अर्ली एज पॉसिबल आई वांट टू कंप्लीट दिस सेशन, बट एटलीस्ट 1 to 1.5 आवर टाइम तो लगेगा, because the questions were little lengthy. So the circuit shown in the figure is used to charge the capacitor alternatively from two sources. एक source तो ये है, ये तो दूसरा source है. And the switches S1, S2 are connected mechanically, coupled and connected as follows. From the time t 2nt to 2n plus 1t. Okay. S1 is connected to P1, S2 connected to P2. So this source is not connected to the capacitor. This source is connected to the capacitor. The second part, when the time t 2n plus 1 to 2n plus 2t, what's happening? S1 connected to Q1, S2 connected to Q2, means we remove this source because we cannot open circuit the current source connected to resistor, and this source is getting connected to this capacitor. Okay, so for n equal to 0, 1, 2, 3, so assume that the capacitor has 0 initial voltage, u of t is the unit step function, and find the voltage across Vc of t, the equation for the voltage across the Vc of t. So please give a try. There is a print mistake here. This is n equal to 0. Okay. This is n equal to 0. जीरो थोड़ा सा शिफ्ट होके प्रिंट हो गया. चलो, so see here, this is the question, okay, and those are the options given, right? Chalo, let's start. So if you are able to, if you know the answer, you can comment the answer यार. नहीं है तो मैं सॉल्व करके देता हूँ. ठीक है, चलो फिर क्या करते हैं. आई विल डू इट. सो आप देख सकते हैं for time t greater than 2n t to 2n plus 1t. So time t greater than equal to 2n t to 2n plus 1t. ठीक है, suppose n equal to 0, it will be t greater than equal to 0 to less than equal to t, because n equal to 0 1 2 3 examiner to diya na already. So s1 is connected to p1, s1 connected to p1, and s2 connected to p2. So if you connect this s1 here, s2 here, so ये source इसको connect किया, so this source is disconnected from the capacitor. So for capacitor only this part is connected. So you can see there is a 0.5 and you have a source and you have a capacitor. 1 ampere, 0.5 ohms, and you have 1 farad capacitor, and this is your VC. So a constant current of 1 ampere is flowing through the capacitor from time t equal to 0 to capital T. So what is the current here is IC. So what is the voltage across the capacitor? 1 by C integral, initial value तो 0 है ना, so 0 से t तक ले लो. कैपेसिटर का करंट I t equal to कब तक? t तक. Current in the capacitor is 1 ampere. So 1 dt. So this will give me, C value is how much? 1 na? So it is t from 0 to t. So your time t equal to t, what is your VC equal to capital T? Right. So it is nothing but a ramp signal. Time t equal to 0 to t. Okay. This is how you are getting the output for the first case. Now the second possibility, t greater than equal to 2n plus 1t to 2n plus 2t. So इस केस में क्या होता है सर? So t greater than equal to 2n plus 1t, say 2n plus 2t. Substitute n equal to 0, so you can say t greater than equal to t to 2t. So here S1 is connected to Q1 and S2 is, so S1 निकाल के S2 यही पे source 2 तो connect किया capacitor को. So S1 to Q1 and S2 to Q2. So you can see here, now the capacitor is having some initial voltage compared to previous case. Previously capacitor के initial voltage तो 0 है ना. Now it is having some initial voltage of T. This is the voltage across the capacitor initially, and now it is the value of the capacitance doesn't change, it remains the same 1 farad. Now for this we are connecting the source. For this we are connecting the source of, you see here this resistor is connected 1 ohm and 1 ampere. ठीक है. So what is this VC? Right. So here the current IC equal to, this is the 1 ampere minus 1. So what is your VC? Initial voltage V0 plus 1 by C integration of कहाँ से कहाँ तक सर? T से 2T तक. What is the current in the capacitor now with respect to the reference positive to negative? -1 dt. So this will give me V naught already I know t minus small t because capacitor value is 2t. If you substitute, this is nothing but negatively going ramp from t to 2t, because if you substitute t equal to 2t, this will become, I mean 2t minus t is t minus t will be giving you Vc equal to 0. So after this process is completed, the capacitor is repeating, I mean, so the circuit is repeating the same. If you substitute n equal to 1 again, you get t greater than or equal to, what is that, t to, sorry, n equal to 1, 2t to 3t, 3t to 4t, 4 to 5, 5 to 6, and so on. This process will be repeated, and the output you will be getting will be like this. So you will be getting positive going pulse, positive going ramp, and negative going ramp, and so on. So this is T, this is your Vc from T to 2T, 2T to 3T, 3T to 4T, and so on. It will repeat the same. Okay. So listen here. So this is what you will be getting it. So it is a triangular waveform. So suppose you see this circuit, it is -1 whole to the power of n, and this is not the right answer definitely, and exponentially not going. So you check between this A and C, and at home you will get C as the answer. I mean इसका भी वेवफॉर्म ड्रॉ करके, इसका भी वेवफॉर्म ड्रॉ करके चेक करो, आपको आंसर आएगा. जस्ट सिंपल सी बात है, इसका स्लोप ले लो 1 होता है -1, so the next extra slope to be added is -2. That is done here. Initially slope is 1, okay, when -1 whole to the power of 1 you take, -2 slope will be added, so that the net slope will become -1. Signals may you will be studying this very easily. So option C will be your answer. Okay, so that is the question from 2008. Now let's do a question from 2019. This is also another question from transient only. थोड़ा सा एक्सपैंड कर सकते हैं. चलो भाई, आप लोग एक बार जान से पढ़ो, इसके बाद वी विल बी डूइंग द क्वेश्चन. ओके, सो मैं आपके लिए टाइम भी दे रहा हूं. शुरू कर रहा हूं, ठीक है? प्लीज गिव इट ट्राई. सो प्लीज ट्राई, प्लीज ट्राई. Come on यार, what happened? Nobody is trying the solution, guys. आप लोग तो ट्राई कर सकते हैं ना. गिव इट ट्राई. So just give a reading first. You have a RC circuit. Our resistance is a variable quantity here. So we cannot apply directly by our regular approaches. What is the formula for R of t? R naught into 1 minus t by t for t greater than or equal to 0 to t. Okay. And what is your t? 3 times R naught into C, where R naught is equal to, what is a R naught equal to 1, C equal to 1, so it can write it is 3. So I can say r of t is nothing but r naught is 1 na, 1 minus t by 3, 1 minus t by 3. Okay, I'll do it. So chalo guys, so let's solve this question normally, conventionally. What is the KVL in this loop? If you apply the current here, the KVL, okay, listen carefully. It's a RC, simple RC circuit. What is your VS? VS equal to I of t into R plus 1 by C, voltage across the capacitor formula 1 by C, integral initial value कुछ नहीं I dt. ठीक है. So here Vs is equal to, so examiner has given any value for Vs. Vs is a constant of 1 volt. 1 equal to I of t I don't know. R value कितना 1 minus t by 3 plus 1 by C value is this one 0 to t I of t dt. So this is my equation. So you need to solve this differential equation by any of your method, whichever you know it. There is no problem. So मैं तो इसमें दोनों तरफ differentiation apply कर रहा हूँ, ठीक है? So apply d by dt on both sides. You get a d by dt of constant कितना होता है सर? d by dt of constant कितना होता है? 0, ठीक है? d by dt of constant तो 0 है भाई. और here in both the sides you need to, so integration of 0 equal to, it is uv formula apply karo, d by dt of u into d by dt of 1 minus t by 3 plus 1 minus t by 3 into di by dt plus differentiation and integration will cancel out and will give you I of t. Okay, this is the equation you are getting. So 0 equal to, what is d by dt of 1 minus t by 3? d by dt of constant तो 0 है भाई, d by dt of t तो 1 है, so I can say minus 1 by 3 into I of t. ठीक है, नहीं तो avoid confusion, I of t into minus 1 by 3 और plus 1 minus t by 3 into d by dt of di by dt plus I of t. ठीक है. So here 1 I of t, you take this other side, 3 minus t can be written as t minus 3 by 3 into di by dt. I have taken this to the other side, I replace 1 minus t with t minus 1. Now it is equal to minus 1 by 3 plus 1, 3 minus 1 by 3 will be 2 by 3 I of t. Just a mathematical part, इसमें कुछ नहीं, दोनों cancel हो जाएगा. So t minus 3 by 2 into di by dt equal to I of t is the equation we are left over. So इस differential equation को solve कर सकते ना? Further 1 by 2 into di by denominator I of t, ठीक है, plus sorry plus 9 equal to dt by t minus 3, ठीक है. So apply integration on both the sides, ठीक है, you get 1 by 2 into d by dt of I of t ln of I of t, ठीक है, equal to ln of was for mathematical convenience I'll take 1/2 here. ठीक है, so 2/t-3 into okay, this is the easiest, this is the one. Now see here, so apply integration on both sides, so you get 2 into ln of t-3 equal to ln of I plus some constant will come k. Okay, it can be you take this side वो दोनों साइड लेके उससे के कांस्टेंट सब्ट्रैक्ट करके एक फाइनल के ले लो. यू कैन टेक एनीथिंग, हियर ले लो, दोनों सारी k1 k2 भी ले सकते, कोई दिक्कत नहीं. सो ln of t-3 whole square equal to, I can write this as ln of I. Let's assume this constant is equal to ln of c is equal to k. That c will be anything, we don't know. So can I say like this, ln of I into c, because ln of a plus ln of b is ln of ab, so ln of t-3 whole square. So दोनों तरफ का ln कैंसिल कर सकते हैं हमने, so ln कैंसिल करो, t-3 whole square equal to ic, I into constant c. So what is your I of t? It is t-3 whole square by c. What is this constant? Find I of 0. I of 0 equal to 0 minus 3 square by c. But I of 0 तो एग्जामिनर दिया, I of 0 तो एग्जामिनर दिया मेरे हिसाब से. टाइम t equal to 0, the current is 1 ampere. Current is 1 ampere, so this is equal to 1. So my c is equal to 9. So what is your I of t? t-3 whole square by 9. एग्जामिनर को कहाँ पे चाहिए? एट टाइम t equal to t/2. t/2 is nothing but 1.5. ठीक है, so substitute here t/2, that is 3/2 minus 3 whole square by 9. You get 0.25. ठीक है, 9 cancel, 1/4. So that is your final answer. Is it clear everybody here? Anybody have any doubt, please feel free to ask me. कोई दिक्कत है तो बताओ, नहीं तो we will go for the next question. Yeah, I as a function of time. I of t is not a constant. Okay, Bhuvaneshwari? चलो next question. This is also a question from transient. Please try. I'll do it anyway, but you try. अदरवाइज दिस इज ए डिजिटल का क्वेश्चन है, बाद में कर सकते हैं. एक्चुअली मैं दूसरा एक और क्वेश्चन करना चाहिए, बट ये आया बीच में. छोड़ दो इसको, वी विल डू इट, नॉट एन इश्यू. पहले ये करके उसके बाद वापस आ सकते हैं. Try this question, yeah. It is a good question. A symmetrical square wave of 50% duty cycle have amplitude plus or minus 50%, 15. So you have a signal like this. This is how much? 15 minus 15. Total will be 30. Right. Suppose firstly, okay, right. This square wave is applied across a series RLC circuit with R equal to 5, L equal to this, C equal to this value. The amplitude of the 5000 radians per second component of the capacitor voltage. ये क्या है सर? थोड़ा सा नया सोच रहा है? Yes. Here the input is not a sinusoidal waveform, input is a square waveform. इसको हम फोरियर सीरीज यूज करके यू कैन राइट इट एज ए सीरीज ऑफ साइनसोडल सिग्नल्स. कोई भी पीरियोडिक सिग्नल हमारे पास है तो अकॉर्डिंग टू फोरियर यू कैन रिप्रेजेंट विथ एज ए सम ऑफ साइनसोडल सिग्नल्स. ठीक है. सो इसमें यू नीड टू फाइंड द कोएफिशिएंट्स ए एन बी एन सी एन ए नॉट, ये सभी चीज तो होता है. ठीक है. दैट यू स्टडी इन योर सिग्नल्स एंड सिस्टम. नाउ एग्जामिनर को क्या चाहिए? 5000 रेडियंस पर सेकंड का कंपोनेंट चाहिए. So please give a try for this. Firstly, what is the time period कितना दिया? Time period t equal to 0.45. Frequency equal to 2 pi by t. 2 pi by 0.4 t here into 10 power minus 3. Pi cancels. Two by 0.4 will give you 5000. So this is the frequency, I mean fundamental frequency omega naught, f naught. F9 omega. Okay. 1 by t will give you frequency, 2 pi by t will give you the angular frequency omega naught. 5000 radians per second is the angular frequency of the signal given by examiner. ठीक है. Suppose you have a signal. For your better understanding, I am giving this also. Suppose this is the signal available. What is the Fourier series of this signal? If you take the peak to peak as A. Okay. So here some people will take 2A and write it. I am taking A and writing it. A naught is equal to 0. Bn is equal to 0. And 2A by n pi sin n pi by 2. This is the Fourier series expansion of this particular signal that you study in your signal for n equal to even. So this is the condition. And also one more thing is all even harmonics. But you need not worry about all even harmonics and all here, because omega not equal to 5000, examiner ko chahiye 5, so he just want n equal to 1 component only. So if you substitute n equal to 1, okay, what is your an? A1 2 into what is your amplitude here? What is the amplitude peak to peak? 30 by n pi. So that will give me 60 by pi. That's the magnitude. Okay. So now let's do this. Here we should write only magnitude I am speaking. Okay. So now because the input is a sinusoidal input of simply as simple as input is a sinusoidal input of 5000 radians per second, but the magnitude of the input is equal to 60 by pi. The magnitude of the input is equal to 60 by pi. Now if you observe here one more important, what is 1 by root LC here? What is 1 by root LC? L value is 10 power minus 2. C value is 4 into 10 power minus 5. So that will give me 10 millihenry, 10 power minus 2. C is 4 into 10 power minus 6 na. So it is a 10 power 4 by 2, because it will be 10 power minus 4 in the denominator. That will give me 5000 radians per second. So one more important point, at here the circuit will be at resonance. It is not needed to solve by resonance, but if you understand it is at resonance, there is another interesting thing is the voltage across capacitor. What is the voltage across the capacitor? I am sorry to do here, no space. It is equal to minus jqv, or the magnitude of this will be qv. Q equal to how much? Omega naught into the supply voltage. Okay. Omega naught is 5000 L by R. So what is the quality factor Q? I am writing 5000. L is how much? 10 power minus 2 by 5. So 0, 0 cancels. Q equal to 10. That is the question. Na? The amplitude of the capacitor voltage 5000 per radian second component of the capacitor in volts. So the magnitude of the input is 60 by pi. Okay, you can do like this, R jxl minus jxc लेके आप टोटल वोल्टेज डिवीजन प्रिंसिपल अप्लाई करके सॉल्व कर सकते हैं. बट मैंने क्या किया, I understood that circuit is at resonance at 5000 frequency, and now in the input I have obtained the resonant 5000 frequency component. Okay, I think n pi will come here. 5000 component का निकाल दिया मैंने, n equal to 1, that is 2a by pi. A is the peak to peak voltage of the square wave, and this is the input. So what is the voltage across the capacitor? Magnitude is 10 times 60 by pi. Okay, that is the answer. अरे यार, ये सभी क्वेश्चंस गेट का है. 70 to 80 is a good one. ठीक है, आप लोग भी ट्राई कर सकते हैं. मैं सॉरी आई हैव सॉल्व्ड इट, बट ओके, दिस क्वेश्चन यू पीपल ट्राई इट. ये तो 2007 का क्वेश्चन है, दैट इज गिवन बाय your IIT Kanpur only in electrical engineering question paper. Yes, you try this question. ट्राई दिस क्वेश्चन, इसके लिए मैं टाइम दे रहा हूं. गिव इट ट्राई. ये सभी क्वेश्चन थोड़ा सा, अरे यार जाओ. 2 मिनट से में तो नहीं दे सकते, 90 सेकंड ले लो. ट्राई दिस. ठीक है, इट्स ए गुड क्वेश्चन. एक दो मिस्टेक्स तो है क्वेश्चन पे, मिस्टेक नहीं, कंफ्यूजन तो हो सकते, बट इट इज नॉट ए डिफिकल्ट वन. आप लोग तो कर सकते हैं इसको. In the figure, the transformer T1 has two secondaries. ठीक है, all the three windings have same number of turns with polarities as indicated. One secondary is shorted by a 10 ohm resistor and another by a 15 microfarad capacitor. The switch is opened at time t equal to 0 when the capacitor is charged to 5 volts with the left plate as positive. Okay. And at t equal to 0 plus, what is the value of Vp and IR? Try this, try this. It's a coupled, I mean, if you are electrical engineering students, magnetic coupled circuits, they can ask you this question. ओके ऑप्शन ये बोल रहा है, मेरा हिसाब से गलत है. बी ऑल्सो गलत. either C or D will come. Let me check. Okay, in the figure, the transformer T1 has two secondaries. All the three windings have the same number of turns with the polarities as indicated. One of the secondary is shorted by a 10 ohm resistor. So fine. Firstly, draw the circuit at time t equal to 0 minus. Switch is closed. This is the circuit with the, this is 25 volts. Okay. You have a resistor. Okay, don't worry with the size of what I am drawing, but he has already given that they are of this one, what we call equal number of turns. Okay, he is saying that it is having, capacitor is having charged to 5 volts. So this is Vc of 0 minus. Capacitor voltage cannot change instantaneously. By using the concept, all dots will be having equal polarities and equal voltages because they are equal number of turns here. So if this is 5, this will also be 5 with the same polarity I am taking. This is the condition. So R is given by how much? 10 by examiner. Okay. So if you apply 10 here, 5 here, what is the current you get? 10 by 5. 10 by 5 is how? And what is the capacitor? Assume steady state mein no current is flowing. Here 5 by 10, 5 by 10, 0.5 amperes will flow in this direction. So in the inductor, above inductor, IL of 0 minus is 0.5. It is equal to IL of 0 plus. So these two informations we can obtain from the given examiner condition. Now let's draw the circuit at time t equal to 0 plus. Let's draw the circuit at time t equal to 0 plus. ये वाला circuit को switch open किया तो क्या होता है? Let's see. The same circuit at time t equal to 0 plus मैंने switch को open किया. मेरा input तो कितना? 25. Resistor is present. Resistor के बाद है ना switch. ठीक है. Now, inductor acts as an open circuit series with a resistor acts as a R. Chalo, here what happens? Actually, you should open this also, but we don't know this initial value. Simply, I am replacing with inductance. Are you open circuited? कोई दिक्कत नहीं. At time t, for sudden changes, inductor current cannot change instantaneously. Because of that, you can replace it with a open circuit. Now, here the current will be how much? 0.5 volts, right? Inductor acts as a open circuit because inductor current cannot change instantaneously. R is how much? R equal to 10, right? Next, here listen here, voltage source will be replaced with a initial voltage and short circuit. What is this? Polarities तो reverse दिया ना exam. ठीक है. And here according to examiner polarities लेना चाहिए. Capacitor acts as a short circuit. Okay, and this 0.5 will be coming here. 0.5 into 10, how much? 5 volts. So this node with respect to this it is a 5 volts only. This is also 5 volts only. So this will be, what is your VP? It will be equal to, you should take here positive, here negative, then it is -5. Dot will be negative here according to the given polarities of the examiner. ठीक है, all dots का same polarity ले लिया तो ये -5 है तो ये भी -5, already we got it, and here also we got the same, and this will also be with respect to the arrow given by examiner, it is reverse. Here minus, here plus you get, that is -5 you will be getting it. And what is the another thing he want? And the current in the resistor. So here you observe, what is the current in the resistor? It is in this direction, so minus 0.5. So what is the answer? -5 and -0. Option D, very good. Option D is the right answer. Next question. So give a try for this question. इट्स ए पावर इलेक्ट्रॉनिक्स का क्वेश्चन भी है, नेटवर्क से भी कर सकते हैं. मैं तो नेटवर्क्स यूज करके कर रहा हूँ. ठीक है, आपका कन्वर्टर्स इन पावर इलेक्ट्रॉनिक्स यू विल डू directly with one single formula also, maybe it is possible, but give a try here. So please try this and tell me the answer of your IP value and T on value. Give a try, please. Please try. Otherwise, there is no use of attending the classes. Yes, time up. Let's see how many of you are able to do it. Just a moment. Very good. 83.3333 is the right answer. NIT पे आंसर नेगेटिव आ सकते. व्हाट इफ द आंसर कम्स नेगेटिव? तो नहीं, दे विल गिव यू द ऑप्शन टू टाइप. ओके, डोंट वरी. NIT में डेसिमल, ओके, इंटीजर, व्हाटएवर यू हैव द आंसर यू कैन टाइप. It's not an issue. 83.33 is the right answer. Okay, let me solve this question. In the figure, switch is operated like this, on and off with a frequency of 10 kHz. So what is the time period of the switch? 1 by 10 power 4, 100 microseconds. That is on time and off time both together equal to 100 microseconds. So circuit is operated at the steady state at the boundary of continuous discontinuous conduction. Okay, fine. On off continuously. So that inductor is high is shown in the figure is. So ये switch on off किया तो आपको ये वाला triangular waveform generate कर रहा है, ठीक है. So find the value of. So ये वाला triangular waveform correctly perfectly generate करने के लिए कितना टाइम तक मैंने switch on करना चाहिए? अगर ऐसा किया तो मेरा को peak value of the current कितना मिल सकते हैं? That is the question. So let us assume it is time t equal to 0. It is t on, this is total t, is my assumption. So here though possibilities, switch is on, switch is off. So let's take the condition of switch is on. So when the switch is on, so अगर switch on पे है तो क्या होता है सर? There is a 100 volt switch तो close किया मैंने, ठीक है, and this is my inductor of 100 microhenry. This is the current IP and there is a diode and 500 volts. Now क्या होता है सर? अभी देखो मेरा डायोड को क्या होता है. डायोड का दिस नोड वोल्टेज नेगेटिव को पॉजिटिव दिया, पॉजिटिव को नेगेटिव दिया, सो डायोड जाएगा ओपन सर्किट हो जाएगा. Diode will be off, that is reverse bias. Diode reverse bias होके off हो जाएगा, ठीक है सर. So when the constant voltage is applied across the inductor, the current in the inductor is given by the formula IP9. I ना. So I equal to 1 by L integration of 0 to t. कहाँ तक में I will keep like this? Switch is on, time t equal to t on. What is its what is the current value? What is the current value here? Is given by 1 by L integral 0 to t v dt. What is the value of v? V equal to 100 dt. So this will give you 10 power 6 into t. It's a sort of ramp signal from 0 to t on, right? So at t equal to t on, as per our examiner given figure, it will reach the peak value. So what is that current at time t equal to t on? What is your I of t is given by substitute time t equal to t on 10 power 6 into t on. That is given by examiner IP. I'll use this later. This is the initial current in the inductor before the switch is open, right? Now when the switch is open circuited, the switch is open circuited now. The same 100 volts is present, but the switch is open now. And now inductor is having some initial current and the same diode is present with this node voltage equal to 500. कोई दिक्कत नहीं, ठीक है. अभी देखो here inductor can be replaced with a current source of initial value IP and parallel with the inductance 10 power minus 4. And this is your I. This is for t greater than equal to t on to t total t, that is during the off time, switch is in off condition. Now what happens? Examiner तो already response दिया, नहीं दिया तो भी कोई दिक्कत नहीं. ध्यान से देखो, ये करंट इंडक्टर करंट cannot change instantaneously. ये करंट जो है ना ये यही तक आएगा, इसमें करंट तो नहीं जा सकते because it is a open circuit. ओपन सर्किट में करंट जाने के लिए आपको इनफाइनाइट वोल्टेज चाहिए which is impossible, ठीक है. So इसमें इम्पल्सिव करंट चाहिए, ठीक है. then this current will come here. Current will come here. Now current will come here. Current will try to here to here. It is KCL को violate नहीं कर सकते. So compulsory current should go like this only. There is no other path here. So current ऐसा जाना चाहिए तो compulsory current is going from positive to negative. This diode will get forward bias. नहीं है तो आपको ऐसा भी ले सकते हैं. इसमें -500 ना ये करंट जाने के लिए इस तरफ में -500 से ज्यादा नेगेटिव दिया तो इट विल फॉरवर्ड बायस. It is easy to give -500 or it is easy to give infinite voltage here. Infinite देके open circuit में current तो नहीं जा सकते. So compulsory दो जो चाहिए ना -500 that voltage is given by the inductor because inductor voltage can be negative when it is discharging. So it will give you sufficiently negative and turn on this diode. ठीक है. So now what happens for time t greater than equal to t on to t, what is the current? What is the current here is given by, that is inductor current is given by, अभी तो already initial current तो है ना, so ip plus 1 by l t on to total t, the voltage across the inductor is -500 dt. So ip कितना होता है सर? 10 power 6 t on plus 10 power 4 because 1 by l is 10 power 4 into t on. So -500 na, so directly I'll write -5 into 10 power 6 because it is 10 power 4, 100 means 10 power 2 into integration of constant is t from, but examiner तो ये दिया है time t equal to capital T, it should become 0. So हो गया question. At time t equal to capital T, your I of t equal to 0, that is 10 power 6 t on minus 5 into 10 power 6 t minus t on. ठीक है. So here 10 power 6 जा सकते हैं, then t on is equal to 5 into t plus 5 into t on. ठीक है. So 6 t on equal to 5t. What is your t on? 5 by 6 t. So 5 by 6 into 100 microsecond, 83.33 microseconds. What is your IP? 10 power 6 into t on. That is already we have obtained here. 10 power 6 t on. That will give me 83.33 into micro and 10 power 6 cancels amperes. So that is the value of IP and t on. Input is there, but resistor is also there, na? Somebody has the doubt. Who is that? Vishwanathan. By using, because the turns ratio is same, I took the voltage division principle same, N1 by N2 equal to V1 by V2. By using that, I took the same voltages. Even you don't take any voltage, 50 क्यों ले लिया मैंने? 5. So 25 will not come because there is a resistor in between. Okay, it depends on the value of the resistor. चलो नेक्स्ट क्वेश्चन पर. सो नेक्स्ट क्वेश्चन के जाने के पहले एक और क्वेश्चन है. प्लीज आई एम टेकिंग ए लिटिल पॉज फॉर 1 minute, so don't go, just the video will buffer for 1 minute and it will restart again. Please wait in the video itself. We are back. Small, I mean there might be a small pause and we are back again. It is also a good question. So all tough possible PYQs those appeared in the previous papers I have collected and I am bringing it for you guys. मैं तो ये सेशन थोड़ा सा पहले स्टार्ट किया तो ज़्यादा क्वेश्चंस ला सकते हैं, बट अभी तो टाइम भी हो गया आपका. आई मीन एग्जाम डेट तो आ रहा है. सो प्लीज ट्राई दिस क्वेश्चन, एटलीस्ट रीड द क्वेश्चन. ट्राई का मतलब गलत भी कर सकते हैं, रीड द क्वेश्चन. Please read. Chalo. Nobody answered the question. Read the question at least. You have a microprocessor controlled measurement scheme for the resistance shown in the figure. The resistance Rx is a unknown resistance to be measured, and R reference and C reference are given. C reference is charged from VL to VH by DC voltage source Vs through R reference in T reference seconds, and then discharged to VL, and it is again charged from VL to VH in Rx time in Tx. So if Tx is equal to K times T reference, then what is the value of Rx is the question. Understanding question itself more difficult here. After that it is not at all difficult. अगर आपको question समझ हुआ तो PYQs are from ECE electrical instrumentation सभी का है, ठीक है, एंड बहुत पुराना वाला भी, जैसा रिसेंट वाला तो नहीं, 90s का क्वेश्चंस भी हटा के मैंने लाया, ठीक है. चलो, सो क्या बोल रहा हूँ मैंने. सो इन द प्रोसेसर कंट्रोल्ड मेजरमेंट में Rx इज द अननोन रेजिस्टेंस. आपको यू नीड टू मेजर द रेजिस्टेंस Rx, दैट इज द अननोन रेजिस्टेंस यू वांट टू मेजर using, while R reference and C reference are the known. Already you know the value of the C reference and R reference. ये पता है, ये Rx तो पता नहीं, ठीक है. So the capacitor is charged through R reference and C reference. Okay, C reference it is charged from VL to VH by a DC constant Vs once through R reference. इसके लिए कितना टाइम लगा? T reference. Then इसको VL करके फिर वापस VH तक चार्ज किया using what we can next time with Rx. इसके लिए टाइम Tx चाहिए, तो what is the value of Rx if Tx and TRF are related by K times TRF. चलो, let me do it, no problem. फर्स्ट वाला कंडीशन, फर्स्ट वाला कंडीशन में ओके, व्हाट इज योर टाइम कांस्टेंट? R reference into C reference, ठीक है. यूजिंग दिस द कैपेसिटर इज चार्ज्ड फ्रॉम वेयर टू वेयर? VL to VH. ओके, नाउ व्हाट इज द फॉर्मूला फॉर VC? VC का फॉर्मूला क्या? VC of infinity plus VC of 0 minus VC of infinity e power minus t by tau. ये वाला फॉर्मूला यूज करके what is the formula for VC is given by what is the final value of the capacitor voltage? What is the final value of the capacitor voltage? Many people here will comment the answer as VH sir, because it is going from VL to VH. nahi, it is the final value will be the value you will get if you leave that circuit up to infinite amount of time like that without any disturbance. That value is nothing but the source value. What is the source value? Vs. So here the final value will be Vs plus initial value is VL minus Vs e power minus t by tau. ठीक है. Now listen carefully. At time t equal to something, t equal to what is that examiner has given? T reference. At time t equal to T reference, what is the value you got it? Vc equal to Vh. Vh equal to Vc equal to Vh. VL minus VS into e power minus T reference by okay tau reference. ठीक है, T reference by tau reference. Next point is second condition. Tau x is equal to Rx into C reference. Here also it is charged from VL to VH. Okay, then what is your VC formula? Final value plus again initial minus final value e power minus T by now tau x. At time t equal to Tx, VC will be equal to VH. So the VH equal to VS plus VL minus Vx. What is T? Okay. Now equation 1, equation 2 दोनों को equate करो. So 1 is equal to 2 because दोनों VHS ना. So VS plus VL minus VS e power T reference by tau reference equal to VS plus VL minus VS e power Tx by tau x. ठीक है. So ये दोनों कैंसिल होके ई कैंसिल हो जाएगा. Then what is the final conclusion you get is T reference by tau reference equal to Tx by tau x. So T reference by C reference into R reference equal to Tx by C reference into Rx. दोनों कैंसिल होके आपको Rx वैल्यू कितना होता है सर? सो ये दोनों कैंसिल अप, ये दोनों साइड एल एन लॉगरिथम अप्लाई किया तो ई माइनस माइनस कैंसिल हो जाएंगे गाइस. ठीक है. नाउ व्हाट इज योर Rx वैल्यू इज R reference into Tx by T reference. बट एग्जामिनर तो ये दिया आपको Tx equal to K times T reference. Use that. Tx equal to K times T reference by T reference. So Rx equal to K times R reference is the answer. Okay, Rx equal to K times R reference. ठीक है, चलो फाइन. चलो लेट्स गो फर्दर. Is it fine, guys? Right, that is done. So how many questions are done? 1, 2, 3, 4. ये तो डिजिटल में करेगा. 5, 6. 1, 2, 3. It is 2015, 2007. I am not sure. 15 I feel. Okay, 15 or 16 हो सकते. 2019, 2008. 1, 2, 3, 4. 5, 6 questions are done. This is the 7th question. So maybe half an hour more I will take the class. Okay, give a try. Right, give a try for this question also. It's also a good question. डिजिटल सर नेटवर्क्स का गुड क्वेश्चंस तो करेगा मैंने इस सेशन पे. डिजिटल तो पॉसिबिलिटी नहीं, बिकॉज ऑलरेडी थोड़ा सा लेट हो गया. पॉसिबल है तो फ्यू क्वेश्चंस आई विल डू इट. सो कैन यू डू दिस क्वेश्चन? ऑल आर गुड क्वेश्चन सर. वन मोर मिनट. ट्वेंटी सेकेंड्स मोर. हो गया टाइम. वेरी फ्यू पीपल आर एबल टू आंसर द क्वेश्चंस. ओके, एग्जामिनर तो ये दिया इस क्वेश्चन पे. The magnitude of VAB equal to magnitude of VBC. Okay. ठीक है. So here what you can understand, the current is same. Okay, I R naught magnitude is equal to I Z angle phi का magnitude. So R naught का magnitude is equal to Z angle phi का magnitude. So you can say R naught equal to Z. R naught equal to Z. I तो same है ना. ठीक है. So don't take if VAB equal to VBC, here total is V. Because they are resistor, I can say blindly V by 2 and V by 2. Here don't make V by 2 and V by 2. Suppose if it is 1, if it is J1, magnitude same hai, but total is not 2. Okay? So total is don't take simply V equal to V by 2 plus V by 2 is V. That is one exception when theta equal to 0. But see, you know that here it is 1, here it is J1 is the magnitude, for example. In that case, individual magnitudes are equal, but total is not equal to sum of individual. ए प्लस बी का मैग्नीट्यूड नॉट इक्वल टू मैग्नीट्यूड ऑफ ए प्लस मैग्नीट्यूड ऑफ बी, ये नहीं करना भाई, ठीक है, दिस इज नॉट करेक्ट, ठीक है, दैट्स व्हाई हियर v/2 मत लेना, ऐसा नहीं होता है, ठीक है, इफ इट इज v इट इज नॉट हाफ एंड हाफ, इफ इट इज 2 1 and 1 आएगा, नहीं आएगा, j 1 and j है तो रूट ऑफ मैग्नीट्यूड ऑफ 1 इज 1, मैग्नीट्यूड ऑफ j इज 1, ओवरऑल मैग्नीट्यूड इज 1 प्लस j का मैग्नीट्यूड क्या, रूट 2, ठीक है, 8 1 का मैग्नीट्यूड 1, j का मैग्नीट्यूड 1, 1 plus j का मैग्नीट्यूड नॉट इक्वल टू 1 plus 1, okay, what is its value, root 2, right, so don't make it v/2 and v/2, so don't divide this as v/2, ठीक है, ओके यार, कोई दिक्कत नहीं, चलो लेट्स डू द क्वेश्चन। सो एग्जामिनर इज सेइंग VBC इक्वल टू VCD, ऐसा पॉसिबिलिटी नहीं है, ओके, VBC इक्वल टू v/2, ऐसा भी कर नहीं हो जाएगा, सो ऑप्शन सी दिया, डी क्यों दिया, डी क्यों नहीं दिया, डी में ऐड कर रहा हूँ, चाचा डी थीटा इक्वल टू 2 tan inverse 2 VBD by V is the answer, this is the answer, 2 आएगा नहीं आएगा मेरे को भी याद नहीं, हम प्रॉब्लम करके चेक कर सकते, ये भी नहीं आएगा, मैं सॉल्व करता हूँ, ये दोनों में एक आंसर हो सकते, ठीक है, सो फर्स्ट फाइंड VBD, what is VBD sir, VBD equal to I into Z angle theta minus नहीं तो वोल्टेज डिवीजन प्रिंसिपल से, ये Z है तो दिस कैन बी रिटन एज R0 एंगल थीटा, बिकॉज R0 इक्वल टू Z ना, सो VBD इक्वल टू VBC माइनस VDC, मेरा VBC क्या होता है सर, VBC क्या होता है सर, VBC इक्वल टू टोटल वोल्टेज इनटू दिस पर्टिकुलर वोल्टेज बाय टोटल इंपेडेंस, दिस पर्टिकुलर इंपेडेंस बाय टोटल इंपेडेंस, सो R0 एंगल थीटा बाय R0 प्लस R0 एंगल थीटा minus V/2, so VBD, you take this V common both the sides, then R0 angle theta by R0 plus R0 angle theta minus 1/2. Next, now V common ले लिया, R0 cancel करो, VBD by V equal to 1 angle theta by 1 plus 1 angle theta minus 1/2. You multiply with 2 both the sides, 2 VBD by V equal to 2 angle theta by 2 plus 2 angle theta minus 1. ठीक है, now this will give me 2 angle theta minus 1 angle theta by LCM ले लिया, that will give me 2 VBD by V. So this will give me, you take minus common, minus 2 VBD by V equal to minus 1 minus plus 1 angle theta by 2 angle theta minus 1 angle theta, theta सेम है तो सब्ट्रैक्ट डायरेक्टली कर सकते, सो माइनस 1 माइनस कॉमन ले लिया तो 1 minus 1 angle theta by 1 plus 1 angle theta, दोनों तरीके मॉड अप्लाई करो, you get 2 times mod of VBD by V. What is this mod? 1 minus, what is 1 angle theta? 1 angle theta is equal to cos theta plus j sin theta by 1 plus cos theta plus j sin theta, ठीक है, mod of 1 minus cos theta minus j sin theta by, so what is the mod of this, root of x square 1 minus cos theta whole square plus sin square theta by 1 plus cos theta whole square plus sin square theta, 2 VBD by V equal to root of a square plus b square -2ab +2ab। इसमें रूट ऑफ फाइनल ऑप्शन पे आ रहा हूँ, 2 - 2 cos थीटा बाई 2 + 2 cos थीटा। ऐसा क्यों हुआ सर? बिकॉज sin स्क्वायर थीटा प्लस cos स्क्वायर थीटा तो 1 हो जाएगा। सो देखो यहीं पे 2 कॉमन ले लिया तो फाइनली 1 - cos थीटा बाई 1 + cos थीटा। So root of tan square theta by 2 is the square, this cancels. So 2 times VBD by V equal to tan theta by 2. So theta by 2 equal to tan inverse of 2 times VBD by V. थीटा क्या होता है सर? 2 times tan inverse 2 times VBD by V. This is the final answer. ठीक है, इतना स्टेप्स तो है। So finally this much, right? थोड़ा सा लेंदी है definitely, but these are not as simple as the questions which we do regularly. Many questions we solve in 10 seconds, 20 seconds, 30 seconds also. There are some questions definitely comes in your exam which takes even 5 minutes also. So हम तो टाइम को डिस्ट्रीब्यूट करना चाहिए, एक दो क्वेश्चंस पे टाइम सेव हो पाएगा, एक दो क्वेश्चंस पे टाइम एक्स्ट्रा लगेगा। सो आप एग्जाम फाइनल्स एग्जाम सॉल्व करने समय पे पहले कम टाइम पे जो क्वेश्चंस होता है ना उसको अच्छे से करो। ये वाला क्वेश्चंस को मार्क का ऑप्शन होता है ना, मार्क करके वापस आके करना चाहिए, क्योंकि इसमें by chance if you miss a half an hour of your time it will be a valuable mistake. Okay, so costliest mistake हो सकते हैं, इसलिए because इतना लेंदी क्वेश्चन में एक स्टेप गलत हुआ तो anything can be possible. So आप लोग ऐसा क्वेश्चन आने समय पे इवन सब्जेक्ट इजी है तो भी टफ क्वेश्चन आ सकते हैं, टफ क्वेश्चन टफ सब्जेक्ट में भी आसान क्वेश्चन आ सकते हैं, कुछ भी पॉसिबल है। सो डोंट ट्रीट एनी सब्जेक्ट आसान और टफ, क्योंकि आसान सोच के हम हर क्वेश्चन आंसर करना चाहिए तो नहीं हो पाएगा, टफ सोच के हर क्वेश्चन छोड़ना चाहे तो भी नहीं हो पाएगा। इसलिए आप सॉल्व करने समय पे क्वेश्चंस कम टाइम पे हो जाएंगे ना, वो तो पहले कर लो। ज्यादा टाइम लग रहा है इस वाला क्वेश्चन को मार्क करके वापस आके करो, बिकॉज इट विल बी द एफिशिएंट मेथड टू डू इट। बिकॉज रेगुलर टाइम नॉर्मल समय पे सॉल्व करने पे प्रेशर हो जाएगा, बाकी क्वेश्चन तो है इस पे टाइम लगेगा, इसमें ज्यादा टाइम लग रहा है, टाइम वेस्ट हो रहा है, ऐसा सोच के सॉल्व किया तो यू डोंट गेट। यू शुड डू दिस काइंड ऑफ क्वेश्चंस विद द फ्री माइंड। ठीक है, चलो। हार्डली 1-2 क्वेश्चंस लाइक दिस विल कम इन योर एग्जाम, बाकी क्वेश्चंस तो नॉर्मल कम टाइम पे हो जाएंगे। हाँ, इट इज रिलेटिवली इजी क्वेश्चन। अभी तक हम जो क्वेश्चंस किया ना इससे कंपेयर किया तो इट्स नॉट मच डिफिकल्ट वन। आई होप यू पीपल डू इट। ट्राई दिस। 20 seconds more. I may take 20 minutes of your time more. चलो, दिस इज द क्वेश्चन हियर। आई थिंक इस क्वेश्चन को आप कमेंट तो करना चाहिए, क्यों नहीं किया? अभी तक क्वेश्चंस किया ना, ये लिटिल मोर डिफिकल्ट कंपेयर टू द क्वेश्चन वी आर डूइंग नाउ, ठीक है। दिस इज अ गुड क्वेश्चन, ये भी ओके, ये भी गुड क्वेश्चन है, ये भी गुड क्वेश्चन है, ये सभी डेफिनेटली ये टफ क्वेश्चंस है, टफ और लेंदी क्वेश्चंस बोल सकते हैं। ये तो डिफिकल्ट नहीं, कॉन्सेप्ट सही है, समझ हुआ तो इट्स एन आसान इजी क्वेश्चन ओनली। So, assuming both the voltage sources are in phase, the value of R required for which maximum power transferred from A to B. Here, your entire B is your load. What is that? Entire network B is the load. So, if you understand that concept, entire network B is my load, then what happens is this entire network B should offer me 2 ohm resistance. Okay, because the maximum power to be taken by the network B means net impedance taken by this resistor, this source also comes into picture. Don't take the Thevenin's equivalent of this. Many people will do that mistake. Replace source with short circuit, Thevenin's is R. You should do Thevenin's equivalent for the load. I mean, for the load we should do it with for the source we do with respect to load. ये load है तो यही से देखेंगे तो source का Thevenin's equivalent तो कर सकते हैं. Source is looking like a VTH and RTH. बट लोड को थेवेनिन्स मत करना, बिकॉज थेवेनिन्स का समय पे वी विल बी नेग्लेक्टिंग द रेजिस्टेंस ऑफर्ड बाय द सोर्स. थेवेनिन्स आरटीएच will be neglecting the resistance offered by the source. So that's why we generally do the problems when RL is given. इसका थेवेनिन्स करके RL equal to RTH कर सकते, यही पे थेवेनिन्स मत करना, ठीक है, बिकॉज थेवेनिन्स RTH will be neglecting the resistance of the source. ठीक है. सो नाउ रेजिस्टेंस ऑफ द सोर्स डिफरेंट है, इंटरनल रेजिस्टेंस तो अलग बात है. सो चलो, सोर्स विल बी अब्सॉर्बिंग सम पावर, दिस विल बी अब्सॉर्बिंग, द टोटल पावर शुड बी मैक्सिमम. सो आप जनरली व्हाट वी कॉल कन्वेंशनली करना चाहिए तो इसका नोड वोल्टेज 3 लेके 10 लेके करंट का इक्वेशन लिख के पावर का इक्वेशन भी लिखना चाहिए. दैट इज हियर यू टेक द लूप करंट I1 I2, इसमें I1 माइनस I2, इसमें टोटल पावर का इक्वेशन करके dp बाई dr करके कर लिया तो बहुत टाइम लगेगा. सो आसान से होना चाहिए, तो क्या करना, दिस कॉमन सेंस से ये पूरा नेटवर्क को हमने 2 ओम से रिप्लेस किया तो मैक्सिमम पावर ट्रांसफर मिलेगा. सो फॉर दैट व्हाट टू डू इज सी हियर. This is the current 3, 7. What is the current equation? 10 minus 3 by 2 plus R. 7 upon 2 plus R. ठीक है. So for maximum power transfer, the network B should offer me 2 ohms. I am not saying R should offer me 2 ohms. The entire network B should be offer me 2 ohms resistance. So in that case, ये तो 10 वोल्ट है भाई 2. दिस इज द इम्पिडेंस ऑफर्ड बाय Z. ठीक है. सो आपको कितना करंट मिलेगा? I इक्वल टू 10 बाई 2 प्लस 2 2.5, और यू कैन सी दिस वोल्टेज विल बी 5, दिस वोल्टेज विल बी 5. सो यूज एनी ऑफ दिस इंफॉर्मेशन. सो I इक्वल टू 2.5 ले लो, इज द रिक्वायर्ड कंडीशन. So if I adjust the value of the resistance such that this current is equal to 2.5, which indirectly tell me this entire equivalent impedance will be equal to 2. इसके लिए हम क्या करना चाहिए भाई? So मेरा equation तो है ना 7 by 2 plus R, ठीक है. So 2 plus R equal to 7 by 2.5, ठीक है. नहीं तो 2.5 into 2 कितना होता है सर? 5 plus 2.5 R equal to 7. 2.5 R equal to 2. R equal to 2 by 2.5. 0.8. So if you keep R equal to 0.8, what happens? If we keep R equal to 0.8, the current will be equal to how much? R equal to 0.8. The current in this whole part will be equal to 2.5. That indicates that this entire network impedance will be equal to, what is that? 2 ohms. Or you can say if it is 2.5 into 2, drop will be 5 volts here. 10 पे 5 subtract करो, ये voltage कितना होता है? 5 ना. 5 by 2.5 will give you equivalent impedance of 2.5. ठीक है. चलो, let's move for the next question. 0.8 is the right answer. 2012 पे दिया है IIT दिल्ली. One of the toughest papers. This is also 2012 का. क्वेश्चन नंबर 7 ना, 8, 9th क्वेश्चन. ठीक है, चलो प्लीज ट्राई दिस क्वेश्चन. इट इज नॉट द एग्जैक्ट क्वेश्चन, मैं थोड़ा सा मॉडिफाई, आई मीन वैल्यूज तो सेम है, बट it is a 2 questions. I just shrink it to single question. 90 seconds time there are. Anybody want to try and give the answer, you can try. Okay, so firstly, the network N is linear and non-reciprocal. What is the linear and non-reciprocal का Thevenin's equivalent voltage formula is K1 into Vin plus K2. That's the relation between the input voltage and the Thevenin's. K1, K2 depends on the network. K2 is 0 if it is a linear and reciprocal network. Linear and reciprocal network में K2 is equal to 0. ठीक है. Now, sorry here. First information. Vin equal to 10. Input में 10 applied. The load resistance RL equal to 7 ohms. The current drawn is 1 ampere. So VTH will be, I don't know. RTH also we don't know. So here, if you connect a resistance of 7 ohms, as per examiner, current is equal to 1 ampere. So I is equal to VTH by RTH plus 7, that is 1. So VTH equal to RTH plus 7. ठीक है. Next, second information. The same Vin equal to 10, RL equal to and I equal to given by examiner. RL equal to 2.5, I equal to 2 ampere. ठीक है. So your input voltage VTH equal to same, RTH equal to same. Now if you current 2.5, the current I is 2. So VTH by RTH plus 2.5 equal to 2. VTH equal to 2 times RTH plus 5. Now, if you solve first equation and second equation, you get VTH equal to 9, RTH equal to 2. 2 2's 4, 4 plus 5, 9. 2 plus 7, 9. Okay, I got the VTH and RTH. When Vin equal to 10, my VTH equal to 9. So, formula क्या है VTH के लिए? K1 into Vin plus K2. Let's take it as a equation 3. So, the last step here, when Vin equal to 6 and he got 1 ohm resistor में 7 by 3 amperes. So, the third point given by examiner, when Vin equal to 6, R equal to 1, it draws a current of 7 by 3. When input changes, VTH will change, but RTH will remain same. RTH will remain same. So RTH will be same for the network. It is independent of the input. Now, if you connect a resistance of 1 ohm, what is the current you get is VTH by 2 plus 1, 3. That is given by examiner 7 by 3. So my VTH is equal to 7. That is again K1 into Vin plus K2, equation 4. What is equation 3? 9 equal to K1 into 10 plus K2. Solve your third wala, fourth wala, K1 to 1 by 2, K2 equal to 4. So what is your VTH formula? Half into Vin plus 4. So half into 6, 3 plus 4, 7. Half into 10, 5 plus 4, 9. Okay. Now listen here. Half into Vin. Now what is VTH? Now determine the open circuit voltage at port B for 8 volts at port A. So open circuit is nothing but VTH for 8 volt at port A. 8 by 2 is 4, 4 plus 4, 8. Okay, so 8 is the final answer. ठीक है, last question number 10 2018 पे दिया, question number 10. Try this question, last question for today's class. Last question. चलो, any answer? Okay, firstly, it's a LC network. So if you apply the Laplace 5 by S DC na SL 1 by SC. So what is the current I of S? 5 by s plus 1 by s. That will give you 5 by s square plus 1. Then inverse Laplace transform is 5 sin t. What is Vc of t? 1 by c integral 0 to t current in the capacitor Ic of t dt. So 1 by c value 1, 5 sin t. So 5 cos t so this will give me 1 minus 5 cos t. So this is your current I. I is 5 sin t. So what is the range of the sinusoidal signal? Minus 1 to plus 1. So minus 5 to plus 5. What is your V of t? 195. 5 minus 5 cos t. What is the range here? Its range is minus 1 to plus 1 cos ka. Right? So minus into minus plus 5, 5 plus 5, 10. If you substitute 1 here, my 5 minus 5, 0. So the range here is 0 to 10. I am not writing individually. Time t equal to 0 में sin 0 is 0, cos 0 is 1, 5 minus 5 0, दो both 0. ये सभी तो छोड़ दो, ठीक है. Now listen here. वो भी कर सकते हैं हम दोनों का वेव फॉर्म्स ड्रॉ करके we can do the problem, but it is not required indeed. Okay, I can do like this. Sin में this one and 5 minus 5 cos t na. Something like this you get up to 10. That is not required. Firstly, your voltage is in the range of 0 to 10. So this is a circle with radius 5 na. Total will be how much? 10. Current is in the range of 0 to 5 to minus 5. Definitely 5 minus 5. Option B is the right answer. Here, what is that? Voltage 0 to minus 10. Wrong na? This is 0 minus 5 minus 10. Here voltage current is 0 to 10. Wrong na? Here current is 0 to minus 10. ये भी गलत है ना? So only B is the right answer. Okay. So this is the range of voltage and current. So this is how the voltage versus current will vary and it will give a circle. So I have included many questions. Pulse दिया तो क्या करना source RC circuit में. This kind of questions regular class में मैंने किया and some more questions of digital भी add किया. If possibility है तो मैं एक और class next I'll take some other day. But exam तो very near है, ठीक है? So the new batches are already started here and tomorrow is the last day to avail the offer at Unacademy to get up to 30% on your subscription. So if you want to take the subscription, don't delay it further. This is the code for getting maximum discount on your subscription. Okay? So don't miss it. So these are our rankers this year and the new batches are started for IRMS and also GATE for 24-25 aspirants and UPSC के लिए आप prepare कर रहे तो UPSC GS and GATE भी आप ले सकते, ठीक है? Use my code. Shankat, ठीक है? For getting the maximum discount on your subscription. That's all from my side. So आप मेरा टेलीग्राम चैनल पे ज्वाइन कर सकते for any kind of help, notes, etc. My telegram channel is also Shankar 10. What is my telegram channel? Shankar 10. ठीक है? Thank you. All the best. फिर मिलेगा. Good night. Thank you.